15 seconds to read it through, jot down some notes, think about what we need to do. Look for information being given that we might need. Okay, first thing I notice is that S, which is usually displacement, is distance. S is the distance, but it's not the distance travelled, it's the distance from the nest. So how is that not displacement? So here's the nest. Doesn't really look like a nest, but anyway, it's a nest. There's the nest, and then the bird flies away and then flies back. And then at a particular point there, if we measure S, we're measuring how far, not how far it's travelled so far, but how far away it is from the nest, how far it is compared to where it originally started. Well, that's displacement, right? That's the whole point of displacement, is it doesn't tell you the distance you've travelled, but it tells you at this time how far away you are from where you started. So if you started in your nest, then at any time it tells you how far away you are from your nest. But displacement adds on another piece of information, which is whether you're to the left or to the right of the nest. So if the bird did fly over that way and then come back, then at this time here, that should be on a straight line. Sorry, it's not drawn very well. At that point there, the displacement would be negative, but the distance would be the same number, but positive. So they are not the same, distance and displacement. And even though they're using the word distance here, it isn't to be confused with the distance that has been travelled up to that time. It's the distance from the nest. Okay, then they tell us that the bird leaves its nest at time t is 0. So they're giving us some information. When t is 0, the bird is in its nest. So the distance from the nest is 0. S is 0. When t is 0, S is 0. Bird leaves nest. And then there's another piece of information they give us, which is that at t is another time that we don't know, S is 0 again, because the bird gets back. Bird's home. Bird is home. So that's some information. Bird is modelled as a particle moving in a straight line, distance from the bird, la 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 la. That's all information, but it was important that I saw that word distance from nest, for sure. Okay, explain the restriction from 10 to 20. This is almost always because something goes negative, but it means graph sketching. And it means you have to explain how you knew what the graph looks like. What I'm guessing, although we'll have to actually do it, is because S is distance, so it can't go negative, and we know that when t is 0, S is 0, and we know there's another time when t is 0, I think probably what's going to happen is that the graph is going to go like that somehow, and then that would mean that after t is 10, distance, according to this model, would be negative, which is impossible. So that's usually the answer, but I'll let you try to draw that graph and see what happens. You can factorise it, that's the clue to how to sketch it. Okay, part B. Find the distance of the bird from the nest. So find t when S is... Find the distance of the bird from the nest when... they're not telling us t. No, they're not telling us the time. Find the distance of the bird from the nest when... Okay, I wrote it the wrong way around. What we're being asked to do is to find S when t is... And then that is going to be a sub-question. So then what we're going to have to do is to find t when v is 0, instantaneously at rest. V is 0. So we're going to do this question first, find t when v is 0. Then that is our question inside question. That is going to give us a t, which we're going to put into S, and then we will find S at that point. So because we're going to need v, we're given S, but we're not given v, we are going to need to differentiate S to get v. Then we can put it equal to 0 and solve it to find the time that they're talking about, and then once we know the time they're talking about, we can sub that in to S to find t. Okay, You've got 10 seconds to press pause and give this a go yourself. Okay, have a quick look. Did you remember the units on the final answer? Because it asks for the distance, not the value of s. So the distance has units on it. The distance, s meters. So your final answer, if it asks for distance, needs to have meters on, whereas if it just said find s, you wouldn't need to put the units on. Okay, I have left this one blank to talk through with you because I think this one was a bit tricky. What you need to know is that quartics look like this. There's a little wibble in the middle, and unless it's just a transformation of x to the 4, in which case it looks like a quadratic. But as soon as you start introducing x cubed bits, x squared bits, xy bits, you get the little wibble in the middle. And the wibble can be two minimum, like a minimum, maximum, minimum, like that, or it could be that it's a minimum and then an inflection point and then up, like that. But the basic shape is like a quadratic. So where does this sit? Well, we can see that s is 0 when t is 0 and s is 0 when t is 10. But how am I going to do? So there's a double root there and a double root there. So I think the only way that we can possibly draw this, I don't think we need to do any more investigation, is like this. A double root at 10 and a double root at 0. And that makes sense as well, because the bird is starting at the nest and flying away, s is getting bigger, s gets smaller again as the bird gets back towards the nest, and then at 10 the bird is at the nest. And then it goes up. So this was a sneaky question because the answer for the restriction is not that the graph would go negative, the s would be negative if t is bigger than 10. The answer is that the s is modelling the distance of the bird from the nest from the point when it leaves the nest for a short flight to when it returns to the nest. After that, the model is not relevant. So the model stops at 10 because that's when the bird gets back to the nest. And that's all we're tracking. We're just tracking from the nest, away and back, stop. So because the bird gets back at 10 seconds, that is the end of us needing the model. If the model continued, if we continued to use it, then what it's saying is that the bird then flies away, 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 never comes back. Okay, just to point out one other thing about the graph. When we solved v is 0 to find when it was at instantaneous rest, the first time it was at instantaneous rest, we found 3 solutions, 0, 5 and 10, and they were the turning points of our graph. Because if you differentiate displacement, you get velocity. And the velocity is the gradient of the displacement graph. So what we found when we were looking for the time when it was instantaneously first at rest, we were trying to find, what we found is this 0, this 5 and this 10, which is the turning points. Right, last thing, let's tick off what we actually did. What did we have to do? We did a question inside a question. One of the questions was to find s at a particular time, and the other one was to find the times when v equaled 0. We didn't have to use information to find an unknown. There was no plus c or any other letters that we didn't know. It did mention instantaneously at rest, and it was talking about distance instead of displacement. So a fairly classic question, this one.